in this lesson, we're going to make sure we know the information we need in order to do volume or capacity with spheres. And we know that this is a more challenging formula because it has so many complicated numbers in it. We have a fraction, 4/3, and then we have our pi r cubed. That's a lot of information. Now, two things to look out for. One, we definitely want to make sure we're using our radius. So in the first case where they're giving us a radius, we know we're just summing. We're taking our numbers. You're taking whatever your radius is. In this case, it's 6. And we're cubing that. And then we're multiplying that by pi. I'm also going to give you the advice that you'll probably want to make sure that when you're getting your radius and you're cubing it, that you're going to turn it into a fraction. So all I mean by that is, in this case, it's 4/3 times 216 over 1 times pi. That's just going to be super helpful. And then you're just going to multiply your fractions the way you normally would. Now, if it says leave in terms of pi, I can just multiply those two and leave pi. If it says to use 3.14 as an approximation, you're literally just going to sub in 3 and 1400s. Now, if you want to leave it as a fraction, you could just do 22 over 7. You could do that. What some kids actually do is they'll do this work first. Like they'll simplify 4 times 216 divided by 3. They'll get 288 pi, and then they'll do 288 times 3.14. And that's fine. If you want to do that, that is absolutely fine. A lot of kids wait to the end. Now, the second thing that might happen is they might give you a sphere with a diameter. So instead of going from to the center, it goes from one end to the other. Don't worry about this. Just take whatever that diameter is and divide it by 2 to get your radius. And then once you have your radius, in this case, I know half of 12 is 6. You're just going to do the same thing again. You're just going to put in your radius, cube it, and times it by pi. All right, so that's going to be the work we're going to do today. Hit pause and let's jump into our first example. And it's actually just going to be one problem. We're going to look at Johnny's work. He has a ball, and we're going to look at the volume and try to figure out, did he do this correctly? Now, in his example, he has a diameter of 30. So that's big key popping up, and we want to know which statement is going to be true. So looking at his work, what do we see? What do we notice? We know that he started with a formula. I can see it. And it's the right formula. Volume equals 4/3 pi r cubed. And then what do you see in his second step? What's different between the first step and the second step? Well, he, instead of an r, you can see he put the 30 in there. So he subbed for his radius. You can see it. Now I see he put 30 in there. So his radius equals 30 is what he has here. All right, and then what's the difference between step 2 and step 3? He ends up getting 27,000. How did he get 27,000? Oh, well, he did 30 times 30 times 30 to get 27,000. So he worked with his exponent. And his final step, he multiplied 4/3 times 27,000 to get 36,000. Then he left his answer in terms of pi. All right, so that's what he did. We went through the steps, and you can kind of break down what he did. So let's look at what do we think is true. Like, is this correct? Do you see anything as a possible error or a red flag or any hot spots in here? Now, if I was doing the problem, yes, we know we'd start. But looking at our work problem, look at the problem. It says our diameter equals 30. So again, what did I say in the last part? If they give you a diameter, you're going to divide it by 2 to get your radius. So our radius is supposed to be equal to 15. So that is where I disagree here in step 2. So our radius should be 15, not 30. All right, so here's the first one. A, his work is correct because he used the correct formula. Well, this statement is true. He did use the correct formula, but his work is not correct. So that is false. His work is correct because they used the correct formula and simplified with the appropriate steps. He did use the right formula and he did simplify it appropriately, but he did not use the right dimension. So his work is not correct. I can't agree with that first statement. His work is not correct. So we're stuck with C and D. His work is incorrect because it has a pi in the final answer. That's not why his work is incorrect. We know we can use that unless otherwise specified. It's okay to leave pi. His work is incorrect because they used the incorrect value for radius. Yes. This is, this is the correct one. That's why his work is incorrect, because he didn't use the right value for his radius. I completely agree. His work is incorrect, and it is incorrect because he used 30, which is our diameter, not the radius. So hit pause so you can jot this down into your notes. And in today's lesson, you're going to do very similar things. You're going to have different types of problems where you're going to actually find volume. And again, make sure you're remembering radius should be from the center. When you're looking at the base, from the center to the outside is your radius. If they give you a diameter, just divide it by 2. Make sure you're taking care and paying attention if you can leave your answer in terms of pi, or if they want you to actually approximate by multiplying by 3 and 1400ths. So pay very close attention to those directions, get some practice in, and I will see you in the next lesson, Math Marvels. Take care.